The purpose of this video demonstration is to demonstrate the capabilities of the video chat and the whiteboard functions. Any minute from now, my mother is going to send me a request for a video chat, which I will accept. We'll establish the video chat, and then we'll go into the whiteboard. Here's my mom calling me now. I'm going to accept this. So, can you see me, Mom?
I can see you, Andy.
Great, I can see you too. So I just want to establish that we have a video chat connection here. We can each hear each other very well, and that's helped by the fact that we're each wearing headphones. If there were not headphones on, we'd have an echo. So it's very important that you have headphones on while we conduct the video chat. I just want to see, I can see me. Can you see me back, Mom? You want to wave? Up, great.
Yep.
Okay, looking beautiful there, as always. Okay, so now let's go into the whiteboard. This is established by going where it says begin session and then into the whiteboard. So I'm going to bring up the whiteboard. My mother is going to do the same thing at the same time. Okay, so I'm on the whiteboard. I'm going to change my name here to Andy. And if Mom, you want to change your name to Mom or Beth or however you prefer to be addressed while we are doing this. Okay, there we go. Now guest is Beth. And now we're going to just do a problem that many of my students have. We're going to create a cube. Okay. Cube looks more or less like this. And I'm going to draw the little lines that connect the cube. And Mom, can you see this cube as I'm building it?
I can.
Okay, great. I'm glad to hear that because if you couldn't see the cube, then I'd be very worried. So now I've built this cube. And a problem that we typically have to do on the SAT is they'll ask us to connect two different points in the cube and tell the distance between them. And you need to know some algebra and geometry to be able to do that. So Mom, if I asked you right off the bat what the distance was between those points in the cube, would you know how to do that?
No, it's been a long time since I took high school geometry. I would not.
Okay, fair enough. So the first thing I had to tell you is the dimensions of the cube. If I tell you that this cube has a volume of 8 cubic centimeters, you would need to know how long one of the sides of the cube is. Do you know how long a side of a cube is that has a volume of 8 cubic centimeters, Mom?
I do not.
You do not. Okay, can you think of a number that if you cube it gets you 8?
2.
2, exactly. That means that each side of this cube is 2 centimeters. Okay, that's a very crucial piece of information. So once we know that the side of this cube is 2 centimeters, we can draw the line that we're trying to establish. What we're really looking for is the distance of this line between these 2 points. Okay? And the method that we use to find that is to draw a right triangle that will connect all of the points. Okay, so Mom, can you see how this is a right triangle?
Yes, I can.
Okay, and can you tell me any of the sides of that right triangle?
The half piece is 1 centimeter.
Okay, do you want to go in and draw where it says 1 centimeter right next to the where you think is 1 centimeter long? Okay, very good. So you've established that this piece right here is 1 centimeter. And you actually write pretty well with your mouse there, Mom. I'm pretty impressed. The next step is to use a little bit of geometry to figure out, oops, I'm using the wrong tool there. We need to draw. We want to figure out how long this side is here, the one that connects this point to this point. And we use an idea called special right triangles to figure that out. Okay, so over here, do you see, Mom? I'm going to recreate that triangle over here. Do you see how the 2 sides are sides of a square, and each of those sides is 2?
Mm-hmm.
So in effect, can you see how I am recreating the bottom side of that square over here on the left side? Okay. This is what we call a 45, 45, 90 right triangle. Okay, and to find the hypotenuse, if each of these sides is 50, then the hypotenuse would be 50 times the square root of 2. If each side was 6, then the hypotenuse would be 6 times the square root of 2. It's just by definition that when you have a right triangle that has equal sides, the hypotenuse, or the longest side, is the length of the initial sides times the square root of 2. So in this case, Mom, can you tell me what you think the length of the hypotenuse is on this special right triangle?
Okay. To be 2 times the square root of 2.
Exactly. It's 2 times the square root of 2. Do you want to go ahead there and write that in on the hypotenuse of the green triangle?
2 times the square root of 2.
Very good. And you can see here for the viewers at home that we're both interacting on the same whiteboard space. I can draw something, and then the person on the other end of the video chat and the whiteboard can draw something in, and we're working with each other in real time. So now that we've established that the hypotenuse of that right triangle is 2 square root of 2, I'm actually going to change my color here because I think that we're writing in colors that are pretty similar. Do you see how over here, this is the hypotenuse of the right triangle that you just told me was 2 times the square root of 2? Okay, so now let's try to redraw that green triangle that's here inside of the black cube. I'm going to draw it for us over here, and then I'm going to ask you, Mom, to fill in the sides that are known. Okay, so you see how this is a basic recreation of the green triangle that's inside the cube? Okay, so why don't you go in there, Mom, and why don't you write in the sides that you know?
1 centimeter.
That's 1. You don't have to write centimeters. That's fine.
Right.
That's 1.
This is 2 times the square root of 2.
Okay, very good, Mom.
Unknown.
And that's the unknown, exactly. That is our x, or when we're dealing with right triangles, we usually call this side C, okay? And we call it C because we use the Pythagorean theorem to find the different sides of the triangle. I don't know if you remember this from when you were in high school or college, Mom, but there's something called the Pythagorean theorem, which tells us that a squared plus b squared equals c squared. Can you see that up there, Mom?
I see it.
Okay,
Yep,
great.
I see it.
And our a and our b in this context are the 2 sides of the right triangle. Okay, so we can say that 1 is our a and 2 times the square root of 2 is our b, and then we can rewrite this equation as 1 squared plus, and I'm going to write this in parentheses, 2 times the square root of 2 squared equals our c squared. So if we can tell what 1 squared and 2 times the square root of 2 is, then we can get a lot closer to finding out what our c is, which again is the distance that we're trying to find between our 2 points, which I've outlined here again. So what I'm going to do, I'm going to erase some of the stuff that we have because it's taking up space on our board. Okay, so I'm going to erase all this stuff here. I'm going to even erase the triangle, but remembering that C is the space that we're trying to find. Okay, so I'm going to erase this down here, and we're going to work through the elements, the a squared and the b squared. Okay, so over here, Mom, we know that I have to change it to draw again. Over here, we know that 1 squared. What is 1 squared?
1.
1. So I can say 1 squared is 1 plus 2 times the square root of 2 squared. Do you know how to square all of that stuff, Mom?
No, I have to say that I don't remember.
Okay, that's fine. That's what I'm here to help you with. To square something that's in parentheses like this, you have to square each of the terms. So 2 times the square root of 2 squared then becomes 2 squared times the square root of 2 squared. And I bet you that you can probably do 1/2 of this, but that you might have trouble with the second part. You know what 2 squared is, right?
2 squared is 4.
Okay, and do you know what 2 times the square root of 2 squared is? Fair enough. The square root of 2 squared is by definition 2. Anytime you have the square root of something and then you square it, you get right back to the thing that was in the beginning. So if I had the square root of 9 squared, it would be?
9. The square it would be 9.
Exactly. The square root of 27 squared would be?
27.
Very good. So the square root of 2 squared is?
2.
Beautiful. Okay, so now we have here 1 plus 2 squared. You told me that was 4.
4.
Times 2 equals c squared, correct?
Correct.
Do you want to write an equation you know what 4 times 2 is, right? I mean, that's easy.
So this is 9
That's 9. Over there you have 9 equals c squared.
equals c squared.
And would you like to add the piece de resistance and tell us what C is?
Yes, I would. Here we go.
C equals 3. Very good. So what you just told me here, that the distance between this point on the cube and this point of the cube is 3. And if you were taking the SAT, you would have gotten this question correct. Congratulations, Mom.
Thanks.
I'm glad that you're happy. So just to recap what we did, we initiated a video chat, we went back to the website, and then we opened a whiteboard space where we were able to work collaboratively. I'm just going to pull up the video chat once again.
Would you like me to do the same?
If you can, that would be wonderful. Can you see me now, Mom?
I can.
Wow. Okay, so would you say that this was an easy task for you?
Yes.
Okay, this is so easy that even my mom can do it. Okay, Mom, thank you very much for playing along. We can exit the video chat now, and then I'll call you in a few minutes to follow up once I process the video.
Very good.
Love you, Mom.
Bye.
Bye-bye.